These are the frequently asked questions for the first day of our combined sections 5.5 and 5.6. Starting with number 15, it says, use the rational root theorem to list all possible rational roots for each equation, then find any actual rational roots. So for number 15, what we want to do again is think of the factors of this constant back here, and that's going to be, I'm going to write that a little bigger so it can be seen. That's going to be the numerator of our fractions. Remember, that's what a ratio is. And then up in front, the leading coefficient, again, when they're in standard form, is going to become our denominator. So back here, our constant is 10, and we think of all the numbers that would divide evenly into 10. We're just looking for integers, so positive and negative 1, positive and negative 2, positive and negative 5, and positive and negative 10 will go on the top. And on the bottom, fortunately, we have a 7 out in front for our denominator, and it is in standard form, so that's the one we want to use, and that's a plus or minus 1 and a plus or minus 7. So as we think about all the fractions that would be available here, what I do is take this 1 up here and divide it by the different numbers that I see in my denominator. So a positive and a negative 1 divided by a positive and negative 1 will, of course, be a positive and negative 1. And then a positive and negative 1 divided by a positive and negative 7 will be a positive and negative 1/7. I go through that process for each of the numbers in my numerator. So positive and negative 2 over positive and negative 1 will give me positive and negative 2. Positive and negative 2 over positive and negative 7 will give me a positive and negative 2/7. Positive and negative 5 over positive and negative 1 will give me positive and negative 5. And then positive and negative 5 over positive and negative 7 will give me positive and negative 5/7. Then with the 10, I have a positive and negative 10 over a positive and negative 1, which will be a positive and negative 10. And then a positive and negative 10 over a positive and negative 7 will give me a positive and negative 10/7, for a grand total of 2, 4, 6, 8, 10, 12, 14, 16 possibles as my actual rational roots. So what I have to do is I need to narrow that down for my real roots. So I grab a calculator, and I'm going to punch this in and then check and see what do I have for real zeros here. So we have 7x to the third minus x squared plus 4x plus 10. And I'm going to go ahead and hit zoom 6. And it looks like I have one. I have one rational root. Now, it looks pretty close to negative 1, so I'll try the table first and see if that is what it is. I've got to get this back to negative 1. I'm going to go ahead and do table set. Something's going very slow here, and I'm worried that it's going to goof up. So let me hit this again to just graph it, and then second table. And at negative 1, it's negative 2. So that wasn't a perfect 0. So I'm going to quit out of there, take another look at my graph, and now I'm going to hit second trace. And number 2, find the zeros, and Blinky is above the x-axis, so I'm going to let Blinky get down below the x-axis and press enter for the left bound. Hit right until he's above, and hit enter, and enter through guess. And that comes out to negative 0.920964. Now, what I want to do is come back to this. I'll write that down. as one of my possibles. Now, the next thing I want to do is just notice that's my actual rational root and kind of think for a second, is that any of the numbers that I see in that possibles list? And this time it's not, and that happens sometimes. So my 0 right here of negative 0.920964 didn't happen to be, remember this is just a list of possibles, it's a list of things to try. So it didn't work out as one of the fractions that we had there. Then the next one that I wanted to look at with you was number 50. And 50 says, what is the positive root of that? So we've got negative 5x cubed minus 2x squared plus 9x plus 30 equals 0. And what I certainly would want to try with this one is to try some factoring by grouping and see whether or not that's going to work here. So what I have to do is group the first two terms together and the last two terms together. And I take a look and I see, well, I've got negatives all over the place in this parenthesis. I'm going to take a negative out and I'm going to take an x squared out. And that will leave me with 5x plus 2. And then in the back, with the 9 and the 30, I could certainly take a 3 out of that. And that would give me 3x plus 10. So this is not factorable by grouping. And that means we have to use our calculator and we have to check and see if we can find any rational zeros that we would have for the calculator. So I'm going to move this down out of the way and punch this in and see if we can find any. So this one is going to be negative 5x to the third and then we have minus 2x squared plus 9x plus 30. I'm going to hit graph. I still have my negative 10 to 10 window. Looks pretty good for 2. So second table, and there it is. It says 2, 0. So what I'm going to have to do is I'm going to have to verify that that's a 0, just checking this synthetically. So the calculator is telling me when x equals 2, I have a 0. And I want to check that. So what I need to do is some synthetic division or substitution, that either name, it depends on what you're using it for. This time we're using it for division. And I have my negative 5x cubed minus 2x squared plus 9x plus 30. And it is in standard form and there's nothing missing. So I'm going to write down those coefficients. And I am going to hopefully find out that this divides perfectly into this polynomial. So I bring down the negative 5. And then remember, outside the box you multiply by the number out in front, which is a. So I'm going to multiply negative 5 by 2 and I get negative 10. Inside the box we always add by columns, so that will be negative 12. And then I need 2 times negative 12, which is negative 24. And then I go ahead and add inside the box, and that'll give me negative 15. Multiply the negative 15 by 2 and you get negative 30. And there's the good news right there. The 2 does work. We get a remainder of 0. So 2, 0 is our rational. Now the other 2 could not be seen in the window that we had. And number 50 just says, what is a positive root of that? The other 2 are quite possibly imaginary, so we did find the root that they wanted. And you do have to verify that synthetically. Remember, we might have punched something into the calculator wrong, so we have to make sure that our answer is actually working. In number 51, it asks us for the remainder when we divide x cubed plus 2x squared minus x minus 6 by x minus 1. Well, I can find that synthetically. And since this is x minus 1, that's in that format of x minus a, and that's the reason I can use synthetic. And then I just put the a value out in front. I check to make sure that it's in standard form, And then I put my coefficients down. And remember that remainder is going to be whatever is in that last slot down there, that last position. So what I need to do is bring down my leading coefficient of 1. Now I'm outside the box and I'm going to multiply. Inside the box, add. Outside the box, multiply. Inside the box, add. Outside the box, multiply. Inside the box, add. And so our remainder is going to be -4 for number 51. Then, number 52 says a polynomial with rational coefficients has roots of -3i and 8 plus the square root of 7. What is the minimum degree of the polynomial? Well, this is something I mentioned to you earlier in the chapter, and that is that imaginaries always occur as pairs. So if 3i is one of the zeros, then a positive, if -3i is one of the zeros, then a positive 3i is also one of the zeros. This also works for radicals. Radical solutions come in pairs. So if 8 plus the square root of 7 is there, then 8 minus the square root of 7 is there. Because remember, in our polynomials, we just have normal integers for our coefficients. So we can't have this 8 plus the square root of 7 hanging out as one of our zeros unless 8 minus the square root of 7 is there to use as a complex conjugate to get us back into our normal integer coefficients. So that would mean a degree 4 polynomial would be the minimum degree for this one. So positives and negatives always coming together when you're using imaginary and radicals. Let me see if I can squish number 53 in here. 53 says, what is y? You know, and we're taking a look at a system over here, and we haven't done systems for a little while, so this is a good review problem. All right, so things to think about as you go through here. First of all, we've got a lot of numbers here. And because of that, because it wouldn't be easy to get x or y all by itself, and if you don't want to work with fractions, then you're probably going to go after this one with what's called elimination or linear combination. So that means what I need to do is get basically my x's to drop out, because what I want here is I just want to know what is y. So I'm looking at the 10 and the 8, and I'm thinking, you know what, I'm going to multiply this top equation by -4, and that will give me -40x. So if I multiply the bottom one by 5, well, then I'll have a positive 40x, and those will drop out. So top equation gets multiplied by -4, and we get -40x, and then we have 24 times 4, which is 96. Doesn't look much like 96. Let me rewrite that up here. So that will give us -96y. And then we'd have -4 times 9 on the other side, which would be -36, because what you do to one side of the equation, you have to do to the other. You do not get a choice. On the bottom, we'll have 5 times 8 is 40x, and that's great because that's going to drop right out there, plus 300y. And then we'd have 14 times 5, which is going to give us 70. Now, we can go ahead and add these together here. That's what we're doing with the elimination. And we have 300 minus 96y, which is 204y. And then we have our 70. And then we have minus 36, or -36 plus 70. It doesn't make any difference. We're going to get 34. So then we'll divide 34 over 204. And at the very least, we can see that these are even. So it might not be a bad idea to go ahead and punch this in and just let the calculator reduce it rather than doing it by hand. But like I said, definitely can go with 2. In fact, we can go with 4. So if we reduce this one, it comes out to 1/6. And they just wanted the y value. So we didn't have to do the x at all. So that's the easiest way probably to eliminate the x and just get the y value there. Then, in number 54, it says, what's the value of the greater solution of this polynomial? It's actually a trinomial there with our 3 terms, and it's a quadratic. And I'm hopeful that this is going to be something I'll be able to do by factoring. So I look at what I have for the problem, and there is no greatest common monomial factor that I can pull out of all of those terms. So then I check for perfect squares, don't have them. So in the front, I'm going to need combinations of numbers that would multiply to give me 6. And in the back, combinations of numbers that would multiply to a positive 5, but somehow add in the middle to a negative 17. Now that's really good news because there are not a lot to choose from here. And with the numbers that we have, I'm starting to think, well, negative 15 and negative 2, that would make this really work. So I want outside times outside plus inside times inside to give me negative 17. And it's right here, because 3 times negative 5 will give you negative 15, and 2 times negative 1 will give you negative 2. So then it's first, last, and last, in that order. And then we go ahead and find the zeros. So 3x minus 1 equals 0. You'd add the 1 and divide by 3. And then 2x minus 5 equals 0. You'd add the 5 and divide by 2. And this one did not ask us for both of them. They want you to think about your answers when you get done. It says, what's the value of the greater solution of this? Well, we have 1/3 and we have 5 halves. And 5 halves is 2 1/2, so that's definitely going to be the larger as we go through that. On the next page, looking at number 55, it says divide. So the first thing I'm thinking in number 55 is, can I do this synthetically? And I see that x minus a format. So x minus 1 is x minus a, which means my a value is 1. Now this one has a missing x term in it. So I have 1x to the 3rd, 5x squared, 0x, and then negative 3. So what I want to do here is just use synthetic and then basically translate my answer when I get done. So we need to bring down the 1, the leading coefficient, multiply, add inside the box, multiply, add inside the box, multiply, and add inside the box. And what we have here, working from right to left, is remainder, constant, x, and x squared. So this is x squared plus 6x plus 6 plus 3 over x minus 1, because that was our divisor when we started. Remember, you always start with the right. The first one's the remainder, the next one's the constant, the next to the first, then x to the second, x to the third, etc., as you work your way out. Then, number 58 has us doing some solving. And again, whenever it says solve, we want to think first, is there a way to factor this? So 7x squared plus 63 equals 0. Common monomial factor in this one is 7, so we would pull that out. And that would leave us with x squared plus 9 equals 0. And x squared plus 9 cannot be factored. There are not two numbers that multiply to positive 9 and add to 0 in the middle term. But that certainly doesn't stop us from solving this, because we could subtract 9 from both sides, and then we could take the square root, and that will give us plus or minus 3i for that solution. So constantly thinking about those methods of factoring and going through the list of what we have. And then we have x squared plus 81 equals 0. And again, there is no such thing as a sum of two squares factoring pattern. It doesn't work. There aren't two numbers that multiply to 81 and add, actually, as you say, they're not two integers that multiply to positive 81 and add to 0. So we're going to go ahead and move the 81 over to the other side, and then we're going to take the square root again. And when you do that, remember you need that positive and negative. So that will be 9i, plus or minus 9i. Then, in number 61, get a little space here first before I start talking about that one. In number 61, it says, write each polynomial in standard form, then classify it by degree and the number of terms. And we don't want to forget how to do this just because we've started to do more complicated math. So standard form means that we have to have that highest power of the variable in front. So this will be negative 5x to the fourth, and then you just keep working your way down. So I'm looking for an x to the third. I don't have one, but I have 6x squared, I have 9x, and I have 11. So now that polynomial is in standard form. I want to classify it by degree, and degree is the highest power amongst all the variables, and it's a 4. So that's going to make this a quartic, because fourth degree polynomials are quartics. And then by the number of terms, well, we have 4 terms here, so this would be called a polynomial of 4 terms. Polynomial of 4 terms. And that should take care of day 1.